This video will have a couple of hints on how to do exercise 1.5 question 17. As you can see here, we've got a theme park, and this is the cross-sectional shape or structure of it, and we know that these sides here can be modelled by this function here. So it's some sort of truncus. We don't know what A and B are, but we can kind of work that out using the information given. The first question actually says find the value of A and B. So what I'm going to do is I'm going to treat this here as the y-axis and this line here as the x-axis. Okay, so I know here that this point here must be, I know if that whole thing is 20 meters across, then I know that this part here, just that bit, must be 10 meters across, and I know that that's got to be 40 meters high. Okay, so I've got that point. I can also get this point as well, negative 10 and 40. And I know that this point here, the y value will be 0, and the x value will be, or that distance from there to there is 50. Okay, and then this one could also be negative 50 and 0. Now I only need two pieces of information to work out what A and B are, because there's only two unknowns in the equation. So what I can do is I can put both of these pieces of information into this equation, and I should get the right answer. So I'll give that a go now. 40 is the y value. That equals A on 10 squared, which is 100, plus B. I don't know what B is. That's the first equation. And then the second equation is 0 equals A on 50 squared, 2,500, plus B. Okay, now I've got these two pieces of information. I can work out what A and B are. I could put it in my CAS calculator, or I could rearrange it and find out the answer anyway. I guess I'll leave you to do that on the CAS calculator. I might actually do it on the calculator, but I'll do it quickly. Okay, so when done on the CAS calculator, it ends up being these two numbers here. These are the exact answers. So 40 equals A over 100 plus B. The space and the other equation, comma A, and then you get those two answers. So hopefully that helps you with that question there. To answer C and D, I'll say generally speaking that for any kind of question, they're either going to give you, particularly in chapter 1 anyway, they're either going to give you the x value and they want you to find, so given the x value, and they want you to find the y value. Or the other way around, they're going to give you, given the y value, and they want you to find the x value. That's predominantly what they're going to do in chapter 1. So let's just have a look at this question here. The ride has a carriage that moves down the outside of the central structure. Okay, so down there. What is the horizontal distance from the starting point? So what is the horizontal distance? That's the x value. So what is the x value from the starting point when the height of the carriage is 20 meters, and the height is the y value? So essentially for question C, they want you to pop in y equals 20, and they want you to find out what x is. And given that now you've got A and B, you can work that out fairly simply. And then D, this one's a little bit trickier. A junior version of the ride is proposed, and the sides of the central structure dilated by a factor of 2 from the y-axis. Okay, so it's dilated by a factor of 2 from the y-axis. Now remembering, any time that we dilate something from the y-axis, we actually are affecting all of the x values. Each x value is actually multiplied by the dilation factor. So each x value is going to be doubled in this case. The way we show this in an equation is we say our original function was f of x, and our new equation will be g of x. So g of x is actually some function of x, but it's been dilated by a factor of 2 from the y-axis, which means it's now 1 on 2 x, f of 1 on 2x. Now what I'll do is I might just pause there for a second. I'll quickly show you how that actually works over here, but if you want to just move on from there, I guess skip to the next part. Here is just a normal y equals x squared graph, and it goes through the point 0, 0, and we'll say the point 1, 1. Okay, if I'm going to dilate everything by a factor of 2 from the y-axis, that means here, this point, instead of being 1, 1, that point there is actually now 2, 1. Okay, and so what I'm saying is, imagine if this is the equation, instead of being y equals x squared, it would now be y equals 1 on 2 x. squared. Notice how the 1 on 2 is in the bracket, so therefore that becomes 1 on 4 x squared, like that. Okay. Now I know that that can also be a dilation by a factor of a quarter from the x-axis, but let's just stick with this one here. So and then we're going to say that the point is now so the y value is now going to be 1. Let's find out what the x value is. So 1 equals, it should be 2, but we're going to find that out. 1 on 4 x squared. So that ends up, where did I go? There we go. That ends up becoming 4 equals x squared, and so x equals plus or minus 2. Now we wanted the plus 2. So that's, I guess that's kind of how it works. That's the connection between the two. You've got the dilation factor here, so every x value is now doubled, but it means that when we put it into the actual algebra equation, we actually have to do 1 on 2 multiplied by every x value. Okay, so 1 on the dilation factor multiplied by the x value will end up meaning that all of the x values are doubled up here. I reckon that's probably the trickiest part of the whole transformations. And if you can get that, the way I've explained it here, that's fantastic. If you don't get it but you know what to do, then that's also okay as well, because in the exam they're not really going to ask you to explain why it happens, they're just going to ask you to do it. So it's better if you can if you understand why and you can explain why, but if you don't and you just do it, then that's okay as well. So coming back to our equation, coming back to our question, this ends up being f of 1 on 2x. So therefore, this new equation would be f of x equals, I need to go back up to my original, and it gets a little bit awkward. I'm going to leave it as a and b. So a on x squared plus b, but you know what a on a and b are, but it ends up being a on 1 on 2 x squared plus b. Okay, so every time we see an x, we replace it with a half x. Okay, and then we can find out what a and b are, and you can make the fraction go up the top and make it all nice and pretty. You can just pop that in the calculator and it'll give you a nicer figure. And I guess then you can answer the second part of the equation, which is what will the diameter of the new top be, and the new base, of the new base, if it's still 40 meters tall. So again, that's asking you the y value is 40 meters tall. What's the x value? And essentially then, therefore, what is the diameter? So I hope that's helped a little bit. If you need any more help, just please let me know. But otherwise, yeah, I hope that works. Thanks.